think that was part or number 4. So what you got to do when you're looking for another initial point and terminal point is you just have to have a vector that points in the same direction and has the same length. What I do when I do this is I don't know if it's cheating, but I think it's super easy if you just think about the slope. If you create another vector that has the same exact slope with a new initial and terminal point, then you win. I mean, that's what it wants you to do, right? So um, here's the vector for part A. Uh, you could just be kind of cheap about it and just go up 2 from each of those points. And so my new initial point would be 0, 2, and your my new terminal point would be that would be 8, and I went up 2, so I'm just going to add 2 to 7, so that's going to be 9. And so this is my new initial point, and this is my new terminal point. But I mean, there's an infinite amount of answers for this question because you could, if you wanted to, pick a random point. Like I'll pick this point down here. So this would be my new initial point. So that would be 3 comma, and it looks like a -8. So 3 comma -8. And to find my new terminal point, I'm going to have to do the same rise and the same run that the original um, vector has. So like and this vector is actually the easiest vector because it starts at 0, 0. I can easily see what the rise is, and I can easily see what the run is. But you know how to count rise and run. You would just go 1, 2, 3, 4, 5, 6, 7, and then the run 1, 2, 3, 4, 5, 6, 7, 8. So I do the same thing for this initial point. I'm going to go up 7. So 1, 2, 3, 4, 5, 6, 7. So my new terminal point, or I guess I could have just added 7 to -8, would be -1. And then my new initial point, since it's 8, that's my run, is my horizontal movement. I would add 8 to 3, so I would get 11. So my new terminal point would be 11, 1, which would be 1, 2, 3. Well, I see the 10. I don't need to count. So I could do 11 and then -1. And so this is the same vector as what we started with, except it has a different initial point and a different terminal point. And I can put this terminal point up there um, with, where it is. Okay. So that's it. That's all you have to do to find a new vector with a new initial point and a new terminal point. Um, well, it's technically not a new vector. It's the same vector. It just has a new initial and new terminal point.